Welcome to Oryx Learning. Today's lesson is on Unit 8, Congruence and Similarity, Lesson 1, Congruence and Transformations. Musa, a curious math student, wants to know why translations, reflections, and rotations create congruent images. How should his teacher respond? If you'd like to find out the answer to this question, please follow along and we'll revisit it at the end. Two figures are congruent if the second can be obtained from the first by a series of rotations, reflections, and/or translations. Translations, reflections, and rotations are called isometries. In an isometry, the distance between 2 points in an image is the same distance in the pre-image. If you have two congruent figures, you can determine the transformation or series of transformations that maps one figure onto the other by analyzing orientation or relative position of the figures. In a translation, the length is the same and the orientation is the same, as seen in the diagram below. In a reflection, the length is the same and the orientation is reversed. And for a rotation, the length is the same and the orientation is changed. Which transformation keeps the length of the line the same and the orientation the same? As we just saw, by definition, a translation is a type of transformation that when applied to a line segment will keep the length of the line the same and the orientation the same. So our answer is a translation. True or false? The following two images are congruent by using transformations. Triangle ABC and triangle DEF are the same shape and size. If you rotate triangle ABC 180 degrees, you will get triangle DEF. Therefore, the two triangles are congruent figures using transformations. So this statement is a true statement. Which of the four pairs of figures are not congruent by using transformations? The two triangles in answer choice A are the same shape but not the same size. Therefore, the triangles are not congruent. Which transformation or transformations would need to be made to map the figure on the right? If you take the image on the left and reflect it over a horizontal line, we will end up with two trapezoids with the same orientation, sitting side by side. In order to map one trapezoid on the left to the one on the right, we would then need to translate it to the right and up. Therefore, we would have a reflection and a translation. Triangle DEF has vertices D, 2, 4, E, 0, 5, and F, -1, 5. Triangle DEF is translated 3 units down and reflected over the x-axis. What are the coordinates of the vertices of triangle D', E', F'? So let's first make a chart. We'll start with the original pre-images. So that's the point D, E, and F. The translation, moving 3 units down, will subtract 3 from the y values. Reflecting it over the x-axis will negate all of the y values, and that will leave us with the points for our image D', E', and F'. So starting with point D, 2, 4, let's subtract 3 from the y value. This gives us 4 minus 3, or 1, for the point 2, 1. Negating the y value, or multiplying it by -1, will give us the point 2, -1. And that is the coordinate of D'. D' is 2, -1. Now let's repeat that process for point E and point F. E starts off as 0, 5. Subtracting 3 from the y value will give us the point 0, 2. Negating the y value, or multiplying it by -1, we will get the point 0, -2. and 0, negative 2 becomes our image. The coordinate for E prime is 0, negative 2. F, negative 1, 5. Subtract 3 from the y value for the translation, which becomes negative 1, 2. Negate the y value for the reflection, which makes the point negative 1, negative 2. And that will be the come point for f prime. F prime is negative 1, negative 2. So back to our original question. Musa, a curious math student, wants to know why translations, reflections, and rotations create congruent images. How should his teacher respond? His teacher should respond, rotations, reflections, and translations do not change shape or size. Since congruent figures have the same shape and size, the three transformations create congruent images. Let's review. Two figures are congruent if the second can be obtained from the first by a series of rotations, reflections, and/or translations. Remember that in a translation, the length is the same and the orientation is the same. In a reflection, the length is the same and the orientation is reversed. And in a rotation, the length is the same and the orientation is changed. That is our lesson for today. Thank you for joining us, and I hope you enjoyed it.